Alright, this is an introduction to Unit 5. And Unit 5 is about different types of quadrilaterals. And in your Unit 5 packet, this should be the first page that you see. And it kind of organizes the different shapes that we're going to see. And I'm going to kind of give a little overview of them. So first of all, a quadrilateral, the definition of that is just a four-sided shape. As long as it's got four sides, it's a quadrilateral. So you guys may, squares, rectangles, parallelograms, all those have four sides, and that's what we mean by a quadrilateral. So one type of quadrilateral is a parallelogram, and a parallelogram, because it's a quadrilateral, has four sides. But more than that, its definition states that both pairs of opposite sides are parallel. So if I were to draw a parallelogram, I would show that the top here is parallel to the bottom and the left side is parallel to the right side. And if I have that, then I have a parallelogram. Okay. There are actually two types of parallelograms out there. One is a rectangle, and by definition a rectangle is a quadrilateral, so four sides, that has all four angles congruent. Now we know that those four angles are 90 degrees, but that's not part of the definition, and it's just something we can show. But the definition of a rectangle is just that it's just four sides, all the angles are congruent. If we were working on proofs, we would be able to prove that if you have four angles congruent, you can get opposite sides parallel and actually be able to prove that a rectangle is a parallelogram. A rhombus, the definition of a rhombus is a four-sided shape, so it's a quadrilateral with all sides congruent. So it looks something like this, and you'd just put the same marking on all four sides. Okay, so a rectangle, all four angles are congruent. Rhombus, all four sides are congruent. And again, you can prove that if all four sides are congruent, then opposite sides have to be parallel, making it a parallelogram. Now what happens if you have a rectangle and a rhombus? Well, that's what we call a square. Okay, so a square has both of those definitions. It's got all four angles congruent, meaning it's a rectangle, and it's got all four sides congruent, meaning it's a rhombus. So that when we say square, what we're really meaning is, hey, we have a rectangle and a rhombus. So square, the definition is all angles are congruent and all the sides are congruent. So those are four types of quadrilaterals that are related to each other: the parallelogram, the rectangle, the rhombus, and the square. There are a few other types of quadrilaterals that are not parallelograms, and one is the trapezoid. In a trapezoid, you only have one pair of opposite sides parallel, and so could be the top and the bottom are parallel, it could be the left side and the right side are parallel. Let's just say the top and the bottom are parallel. And the sides that are parallel are what we call the bases. So it's got two bases. This would be base 1 maybe, and this would be base 2. It doesn't matter which one's base 1, which one's base 2. But this thing would have two bases, and then the other two sides would be called the legs. So leg 1, well, and leg 2. Okay, so those are the legs. If you have, there's a certain type of trapezoid, we call it Isosceles Trapezoid, and that would be a trapezoid where the legs are congruent. So we have one pair of opposite sides parallel and the other pair of opposite sides are congruent, so the bases are parallel and the legs are congruent. So that, if we were to draw that, we'd show maybe the top and bottom parallel, or you can do the left and right, doesn't matter, and then the other two sides would be congruent. The parallel sides will not be congruent, but the legs would be. And that's what we mean by an isosceles trapezoid. And then the last type of quadrilateral that we are going to study, there are others out there, is a kite. And a kite is defined as having two pairs of adjacent sides congruent. I'll talk about what that means. But opposite sides cannot be congruent. So adjacent, that word adjacent means next to each other. So if we have four sides, so it's a quadrilateral, two of the sides next to each other are congruent, the other two sides next to each other are congruent, but the sides across from each other are not congruent, right? And that's what makes your kite shape. So part of your homework is to memorize these different shapes, okay? Quadrilateral, parallelogram, rectangle, rhombus, square, trapezoid, isosceles trapezoid, and kite. So there's 8 different key shapes. Memorize what those are, and also memorize the definitions. So what I highlighted in yellow, memorize a quadrilateral means it's a four-sided shape. A parallelogram means both pair of opposite sides are parallel. Understand what that means, okay? Now these shapes also come with properties, and on this diagram I have boxed in the properties. And so for example, the quadrilateral, you can see boxed under the definition is the property that the sum of the interior angles is 360 on every quadrilateral. So that's true for everything on this page, because everything here is a quadrilateral. And if you add up all the angles inside, you will get 360. Again, that's a property, something that can be proved. It's not part of the definition, but it's something that we could prove if we had a unit on proving. Don't worry, we're not gonna be proving in this unit. But there's definitely things we could have proven. A parallelogram has 4 key properties that can be proved, and you need to know these 4 key properties. And I'll talk about them here, but then I'm going to show you some more stuff. So first one is that the consecutive angles are supplementary. So what do we mean by consecutive? Another way is angles next to each other, or I could say adjacent angles as well. And so if I were to draw a parallelogram, okay, so opposite sides parallel, and if I were to number these angles, angle 1, 2, 3, and 4, you pick any 2 angles that are next to each other. It could be 1 and 2, or 1 and 4, or 4 and 3. They have to be next to each other, and if you add those measures up, you're going to get 180 degrees. So I'd say something like this: measure of angle 1 plus the measure of angle 2 is going to be 180 degrees. That's what we mean by consecutive angles are supplementary. Second thing is opposite angles are congruent. So angle 1 and angle 3 would be opposite of each other, and so they would be congruent to each other. Angle 4 and angle 2 would be opposite of each other, and so they would be congruent. So we could say something like angle 1 is congruent to angle 3. We have opposite sides are congruent. So if I were to draw, say this is if it's a parallelogram, then these would be opposite sides, these would be opposite sides, which is different than a kite. Remember, the kite opposite sides are not congruent as part of that definition of a kite. So you know a kite can't be a parallelogram. because the parallelogram opposite sides are congruent. And then the diagonals bisect each other. What do I mean by that? Well, they cut each other in half. And we've looked at other proofs where diagonals bisect each other, but we would be able to, if it's a parallelogram, we could show, and if here's my two diagonals, that this diagonal would be cut in half, so the two halves would be congruent, and this diagonal would be cut in half, so those two halves would be congruent. And that's true for every parallelogram. Now look at our diagram. I'm going to back up here. A square, well, let's look at a rectangle. A rectangle is a parallelogram, so because of that, a rectangle inherits the properties of a parallelogram. So we can, all four things that I highlighted in green, I can apply to a rectangle. So I could say, well, since a rectangle is a parallelogram, consecutive angles are congruent, are supplementary, opposite angles are congruent, opposite sides are congruent, diagonals bisect each other. Also, a rhombus is a parallelogram, so the rhombus inherits the properties of a parallelogram. And then a rectangle and a rhombus are both quadrilaterals, so they inherit the properties of quadrilaterals, right? And then the rectangle has its own special property that most parallelograms don't have, but a rectangle has the property that its diagonals are congruent. Whereas a rhombus has these special properties that the diagonals are perpendicular and diagonals bisect opposite angles. And I'll talk about what those mean in a second. But I'm just giving you a big picture here. The square inherits all the properties of a rectangle, all the properties of a rhombus, all the properties of a parallelogram, and all the properties of a quadrilateral, because it's all of those things. And so this diagram kind of shows you the relationship between different pieces. And again, you want to, as you're memorizing the names of these different quadrilaterals and the definitions, and you got to memorize the properties, everything I'm highlighting in green, keep in mind the relationships between them. So again, part of your homework is to memorize everything on this page. And I know it's a little bit, but treat it like a Spanish class or a history class or an English class where you got to memorize certain things. You can create different flashcards if you want, or there's things online that can help you memorize. Whatever helps you memorize these things, you want to get to work on that quickly, because you don't want this to be in the way of you not being able to solve the problems that we're going to be able to do. The quicker you get this memorized, the easier job you're going to have in this unit. Okay, and so I'm asking you that by the next time we are together, that you have this memorized, and just work on it as quickly as you can. Now let me show you the next page in your packet, which is it's a bit repetitive of the first one. It's just organized differently. So if you really understand the first one, this is just a repeat, but it's helpful. I have a little bit more written here. For example, the quadrilateral, right? You have a picture of it, you have the definition, and you have the same property that all four angles add up to 360. Right? So you just have the definition and the property. Or the parallelogram, what I have here, you have the definition, opposite sides are parallel. What does that look like if I were to label A, B, C, D? AB is parallel to DC, AD is parallel to BC. You have a picture of a diagram. And then the four properties, I didn't put them in this box, but you can see that I said C number 1, 2, 3, and 4. And if you if you scroll down a little bit, or if I scroll down a little bit, you see these 4 properties here. There's your 1, 2, 3, and 4. Those are the 4 properties that would apply to the parallelogram. And I just have more details in here that help you understand what they mean. So there are a total of 8 different properties out there that apply to the different shapes in different ways, and then these are the 8 different shapes, and it states which properties go with which shape. Okay, and so this paper right here has everything you need to know. The only thing that this one's missing that the first one has is the first one's just a nice picture of showing you how they're related to one another, right? You don't get that on the detailed page, and so you want to have this relationship or this mapping in mind, because that can help you. Because if you've already memorized the parallelogram and the 4 properties that go with it, and then when you get to the rectangle, you only need to memorize 1 more property, because you know that the 4 properties that go with the parallelogram also apply if you knew that relationship. Whereas if you were over here looking at this page and you're trying to study the rectangle, it would appear that you have to memorize 5 different things, and you don't, because 4 of those came from the parallelogram, right? So understanding these relationships can be very helpful to you. So this page, make sure you read through it all, make sure you understand everything that's there. I didn't go over everything on these. There's some other information on here that is really nice and helpful. I only put stuff on here that's helpful and that you're going to need as we're working through the problems in this unit. So again, everything on this page should be memorized. Okay, but it's a repeat of the first page. So we're going to combine all those properties and quadrilaterals and definitions with factoring. We did a unit already in I think it was our 2nd unit together on factoring, and we learned that there were 5 different types of factoring, and in that unit we talked about how to solve by factoring. And then I made you solve by factoring again when we did unit 4, and then it's coming back again here. So we're gonna make factoring a big part of this unit, and you wanna understand it. Is factoring something that will go with you to all your future math classes, and this is something we can't avoid, and we want to understand and be really good at it. And so every problem in this unit will involve factoring, and so there's no way around it, no way to get a problem right without knowing how to solve by factoring. So what I made for you is a summary of what you need from unit 2 here, and you could see I gave an example step by step for type 1 of how to solve if you're using the difference of 2 squares, right? And I have just worked out nice example and the steps that go with that. I did that with the 2 perfect cubes as well, and then you look, keep going to the next page, we have one with type 3, which is with the GCF, type 4 with the grouping, type 5 and 6 are just two different examples of the same type of factoring, trinomial factoring. And so these are going to be, this is repetitive, this is stuff we have already done, in Unit 2, but this is summarized for you so you can go back if there's something that you haven't learned. This is a great page to go back over and to study and to try these problems and to understand the steps. Or if you're stuck on a problem that we're working on, this will be a great reference sheet for you. Okay? So let's go look at what a problem is going to look like. And so this is coming off of the Math 2 Honors Unit 5 Homework 1. So number 1 here says given parallelogram ABCD. So it's telling us that what we have here is a parallelogram. Then it says to solve for x if the measure of angle D is, they give us the equation x squared plus 2x plus 20, and the measure of angle C is x plus 160. So in my diagram I'm going to take note of where those angles are. Okay, so angle D is right here, I'll mark that, and angle C is right over here. Okay, and I want to know how they're related to one another, because if I know how they're related to one another, then I can write an equation to help me solve for x. But in order to do that, I have to know something about parallelograms, right? So that's why I'm saying we really have to know what's going on here. And in a parallelogram, we have 4 properties that might apply. We're dealing with angles. Only 2 of these properties deal with angles. One is consecutive angles are supplementary. The other one is opposite angles are congruent. If I go back to my homework, looking at angle D and angle C, those are not opposite angles, they're consecutive angles, they're angles right next to each other. And so the property that I'm going to use, I'm going to write in here, consecutive angles are supplementary. Which means they add up to 180. So I know that the measure of angle D plus the measure of angle C is 180. That's what it means to have consecutive angles supplementary, and we know that because it's a parallelogram. They told us that. So now I'm going to substitute in my equations. So the measure of angle D was x squared plus 2x plus 20 plus measure of angle C is x plus 160, and all that's going to add up to 180. And this is when it becomes important for you to know how to solve quadratics, right? And that's why if you get stuck or you forget, you may want to go back to this type of or this page. And if you don't know what type you're doing, that's okay. They all start the same way. So you just pick one and look at step 1. Step 1 says set the equation equal to 0, right? And then make sure the terms are in order from highest power to lowest power. Make sure your highest power term is positive. All the step 1s say that. So it doesn't matter which type, that's our step 1. And so back to our homework. So I am noticing that I copied down the measure of angle C wrong. I put 16 instead of 160, so I need to fix that before I move on. But our goal, or our first step, is to make this equation equal to 0. I am going to first, before I make it equal to 0, I'm going to combine some like terms. So 2x plus x, I can add those. Remember, like terms have the same variable, same power, and then 20 and 160 are both constants, they're like terms as well. And so we have an x squared plus 3x plus 180 is equal to 180. And our goal is to make sure, or our first step is to make sure this equation is equal to 0, so I need to subtract 180 from the right side. Whatever I subtract from the right side, I get to subtract from the left side. And I'm left with x squared plus 3x equals 0. Okay. If you get stuck at that spot, now what you can do is go back and look at the solving by factoring, and where you're looking is at the place where we're equal to 0. So we have this right here, right? We are at two terms. So if you're left with two terms, you may want to factor difference of two squares. Here we have two terms as well, so you want to look out for two perfect cubes if you have that. Or you may have two terms and it may be factoring a GCF. The other types have more than two terms. We have four terms with the grouping when it's equal to 0, and we have three terms when it's trinomial, right, when these are equal to 0. So I'm just showing you where you would look if you're trying to figure out, well, which type am I using? You're looking at what happens on these problems when they're set equal to 0, and how can I compare that to the one I have. So the one we have has two terms, and so we need to check, is it a difference, a minus sign between two perfect squares like type 1? Do I have two perfect cubes like in type 2? Or do I just have something like type 3 where I can factor out a GCF and get, just they both had an x, I pulled out an x. So we go back and look at our homework, and our two terms, yeah, they both have an x that we can factor out. So this would be using the GCF factoring type. Okay, so this is, I'll just name it here. You don't have to do this on your homework, but just for your sake of maybe looking back, you may want to put that there to say, okay, this is that type. So I'm going to factor out an x, and I'm left with an x plus 3 equals 0. Right? And if you get stuck there, what do? Go back and look at the example I gave, and you'll see there what I show to do is to separate your factors, set them equal to 0, and then solve for x. So the first one's already done. We got x equals 0, and the second one we subtract 3 from both sides and get x is negative 3. Okay, so also for part of your homework, I just want you to do number 2. Okay, we're going to do the rest, save the other problems, but I just want you to do work for one problem, just like I did on number 1. Try to do it for number 2. You got to fill in the box and say what property are you going to use, and go ahead and solve for x however you think you can. You got to set up that equation and work all the way through it. So to recap, your homework is to memorize the names of the shapes, the definitions of the shapes, the properties of the shapes, and the relationship between them. Okay, lots of memorizing there, and then to do one problem, which is number 2 here. And we'll pick up from there.